Sichangi. I work at the Center for Mathematics, Science and Technology Education in Africa, CEMASTEA, based in Nairobi, Kenya. And this institution is the one that has organized this training for teachers of junior school. And the theme of the training is virtual laboratories in STEM education. As you all know, we have physical laboratories in our schools in Kenya, and sometimes in some remote areas, there are no adequate resources in these laboratories. And this program has been developed to actually mitigate the challenges of lack of laboratories or lack of material resources for teaching the STEM subjects. STEM subjects are quite practical, and therefore we all know that we need to engage learners in practical activities, conducting experiments, and exploring the comparatively abstract concepts in mathematics. This 3-day workshop was organized by CEMASTEA countrywide, and as we talk, we have been able to go through the content of the course with the teachers of junior school here in Sichangi Girls. And during this training, we introduced the teachers to the CEMASTEA developed virtual laboratories. They have been able to access them and also explore the features in there. They have also used them to prepare an ICT integrated lesson that uses a virtual science or mathematics laboratory. Lastly, we have also been able to engage them in peer teaching. They have been able to peer teach each other using the developed lessons. And after peer teaching, they have done debriefing. They have also been able to critique the lesson successfully. And we have been happy with how they have embraced the concept of virtual lab. As we release them to go and practice the tenets of teaching through virtual laboratories, we are a delighted institution because these teachers now are confident and they are able to go and interact with their teachers using the resources that we have deposited in the virtual laboratories. Thank you so much. Thank you.
Yes, maybe a question. You're saying you're doing it nationally?
Yes.
So, like here in Baringo, how many teachers have you trained or how many schools?
In Baringo, we have 2 training inset centers. A group of teachers of 144 are being trained at Kapopita Girls High School in Kabarnet Town. In Solian Girls High School, here in Koipatek, we have trained 95 teachers from junior school.
So they're covering the entire Baringo. Representative from almost all the schools?
Yes, these teachers are drawn from all the schools in Baringo County. A representation. Selected at least 2 per school.
So maybe you can tell us, because what I believe is you are trying to fill a gap, maybe in terms of facilities that these schools don't have, laboratory facilities. So by introducing virtual, maybe it will be able to put them at par with the institutions that have or give them those necessary facilities virtually. So maybe you can highlight.
Yes. I would like to use an example to show how the virtual labs complement a school that either have a laboratory without resources or they have resources but they are not able to innovatively use that resource. In the virtual lab, for example, when you are teaching a concept of electricity, you notice that in this virtual lab we have put a manipulative resource or a simulation resource that enables teachers to demonstrate the flow of electrons and how electricity then gives rise to a power source. And children are able to interact with that simulation to illustrate a concept that is quite abstract. Generally, in a physical laboratory, you will find they connect wires to be able to see that the bulb is lighting. But in this context, they go beyond and see that there are electrons moving in that wire to create the light energy. And therefore, the virtual lab play a two-way role. One, is enhancing the abstract concept, a scientific concept that is very abstract to teach, even for the teacher. Secondly, it serves the purpose of filling the gap of lack of resources. So it plays a greater role. And then, of course, attitude. You know, when you are able to illustrate the flow of electricity, it's exciting. Children get excited to see, oh, this is how electricity is traveling through a physical wire to translate into light energy.
So there's a concept of maybe audiovisual, which may be interesting to the students.
Yes, the audio and the simulation. The audio and simulation are very powerful ways of communicating abstract concepts in STEM to learners. You can also encounter a subject like mathematics, that we have provided a tool in the virtual laboratory of doing geometric constructions. This morning they have been illustrating how to construct a right angle triangle virtually and being able to calculate and determine the Pythagorean theorem virtually. That is interesting because again they will be able to appreciate the relationship between the three sides of a right angle triangle and how they form the Pythagorean theorem. So in short, we are actually helping teachers through the virtual labs to teach STEM subjects from first principles, how the concept was originally developed, which is a journey that will be very exciting to the children as they learn STEM subjects. And we hope that they will motivate the children, more children to join into the STEM education. They will also enhance understanding because in competence-based education, we don't teach for exams. We teach to build competences. And if a child is able to innovatively interact with a simulation to generate electrons, then you are creating competence, not just mere hearsay. Thank you.
Where's the origin of this virtual labs? Did it start in Kenya or you adopted it from somewhere?
Okay, the virtual lab is not a new phenomenon globally. It has been there, and maybe 2 to 3 years ago, CEMASTEA has been using virtual labs by other developers in the US who also have tapped local knowledge in Kenya here to work for them. And some of them used to be our trainers. And through that, we decided that our institution that since we are implementing competence-based education, which is well known to CEMASTEA, it was better to customize local product that will then speak to the competence-based education curriculum and also speak to the realities of our country. So this is not a project that CEMASTEA has just started today. We have taken about 2 years trying to work in the back end to create simulations that are aligned with the current curriculum of this country. And the challenges of importing the same from other countries, you will find there have gaps to meet the local needs, and it is not